Okay, this is exam 3, problem 11. And here, we know that we're saying sigma is less than or equal to 10. That's the standard deviation, yeah. And we want to know n equals what, so that our margin of error for a 95% confidence interval, is that margin of error, which we'll calculate by using, and here's where we don't know, let's start with a z alpha over 2 times that sigma divided by the square root of n needs to be less than 4. Okay, because we want a plus or minus 4. Now, so if we do that, this says the square root of n has to be greater than our z alpha over 2 sigma and divided by 4. Now, so if we go with that, then I got my z alpha over 2. Well, we know what z alpha over 2 is. It's 1.96. So that's 1.96 times 10 divided by 4. And so that's 19.6. Is that right? It seems smaller. What are my answers? What did I just look at? Let's see. So 1.96, 10, that's 19.6 divided by, oh, yeah. Whew. Gosh, I forgot I hadn't squared things yet. Okay, so this is what, 1636, 4.9? Is that right? 4.9. And then now when you square that, so you get n greater than, I think that's 24.01 or 24.1. Yeah, I think it's 0.01. Now, here's the thing. I gave people credit. If you came up with this answer and you said n greater than or equal to 24, I gave it to you. But technically, right, you didn't make it if you were at 24 because this is 24.01. So really, this should be n greater than or equal to 25. Okay, so you come up with this kind of answer if you use z. Again, I gave it to you if you said 24, but now here's the thing though, is, ooh, you do that and then all of a sudden you realize, ooh, that's considered a small sample. And I think one person, when I was looking at this, actually mentioned a known sigma. And so, if sigma is known, so if that's known, z is okay. Okay. Is it known? Not really. Again, if you wanted to go with z, if you're saying sigma is known in the sense that, well, hey, somebody's saying it can't be any bigger than 10. Well, I guess in that way we know something about it. Okay. So in that case, really, the best answer is 25, not 24 here because of the 24.01. But again, I went ahead and gave 24 as a fine answer. Now, so what do? Well, we could turn this instead of, use a t alpha over 2. And now here's where it gets really strange because you need n minus 1 degrees of freedom. So you could play around with it, with different degrees of freedom. But I know I want n at least 25. And so, I could look at maybe the biggest n that's associated with n equal 25. That would be 2.06, something like that. So t 0.025 and 24 degrees of freedom is equal to 2.06. So I could kind of try that. Now actually it stays at 2.06 up to, so this is 25, 26. All of those actually are equal to 2.06, and it only goes down to 2.05 at 27. And so, maybe use 2.05, something like that. In which case, you'd look up here and you just got that. Well, all you got to change is the 1.96. So you got the square root of n needs to be bigger than, let's go with let's use 2.06, I guess, times 10 divided by 4. Well, that's 20.6 divided by 4, and that's 5 and 0.15, I guess, 5.15. And so n has to be bigger than, oh shoot, what the heck is 5.15 squared? Let's see, 5.15. If I can reach the keys here to do a squared. Yeah, that's 26.5. So n is greater than 26.5, and that would mean n greater than or equal to 27. Okay, so yeah, if you use the 2.06, 2.05 would give you something basically the same and give you 27. So, I'd feel pretty comfortable with 27 there. Okay, so 25, I took actually 24. A better answer is 25 because of the 24.01, but it's really, really close there. And then really the better answer yet is 27 because we really probably ought to be using a t distribution, but it gets a little nasty in there because that number keeps changing, but it doesn't change that much. These are all 2.06, and by the time I get to 27 degrees of freedom, which would be 28, so this is the right degrees of freedom for 26 there. I mean, well, N27 is 26 degrees of freedom. And so it all works out. And so we'll call it 27. Seems like a good answer for that one.